Israel is known for turning deserts into farms and making scarce water useful. But one of its boldest moves goes beyond farming or desalination. It built a huge man-made river through the dry desert, changing the nation's economy and daily life. This wasn't just about water, it was about linking cities, helping development, and creating chances where there were none. Millions of tons of dirt were moved, pipes stretched across harsh land, and amazing engineering made life possible in dry areas. How did Israel achieve such a risky project, and what dangers and benefits came from shaping nature like this? Join us in this video as we reveal the details. The southern part of Israel, especially the wide and lonely Negev desert, was once a place where daily life was almost too hard to imagine. The land was dry in a painful way, not just a little dry, but dry to the point where the ground cracked open and stayed that way for months. The sun burned so strongly that it felt like it was pressing down on everything, and the heat rose so high during summer that temperatures often climbed well above 110 degrees Fahrenheit. This intense heat made planting and farming feel like a battle that people had no way to win. Rain arrived only for a short time each year, and when it did come, it came in small amounts that disappeared almost instantly into the thirsty earth. Over the years, the water hidden beneath the ground also began to fade away, little by little, until families started to notice that there just was not enough left to grow crops, take care of animals, or even live comfortably. Many families had to depend on water brought to them by trucks that traveled from faraway places, just so they could cook, drink, or wash. And even as people struggled with this extreme dryness, the Mediterranean Sea sat only a short distance away, full of water, yet completely undrinkable because of its heavy salt. This closeness of endless water, paired with the land's desperate need for it, created a sharp contrast that pushed the country to consider an idea that sounded bold, unusual, and almost unbelievable: bringing seawater deep into the desert and trying to give real life back to a land that looked too dry to recover. The country eventually approved a massive water project around the year 2000, making a decision to invest almost $3 billion into it. This large sum of money made it very clear how loyal and serious the nation's leaders were on changing the desert's future. Moving seawater across the dry land was only one part of the idea. The true goal was to change salty saltwater into clean, pure water that farmers could use to grow crops and that people could drink. It turned into a direct challenge to the desert itself, as though people were trying to create a river where none had ever existed. Teams of experts went into the desert to properly check the area before any machinery could begin digging or building. Because the desert is always changing and can change quickly, they spent a lot of months taking down every information they could. In order to check what was hidden under the sand, these teams used high-level tools and equipment, checked the strength of the winds during each season, and checked how the sand dunes moved. In order to check the soil layers under the earth, they dug hundreds of deep holes, some of which reached depths of over 100 feet. They marked the planned path for the water system by placing markers by hand, checking and rechecking every point until everything was exactly in the right place. All this slow and detailed work had to be done before anything else could begin, because even one wrong path could mean that a single sandstorm might bury the project overnight. When the route was finally mapped out, large bulldozers and construction machines moved in to prepare the land. In order to make the land more flat enough to carry big cars and machinery, they slowly removed tall dunes and drove the sand into lower parts. However, the sand was too weak and loose to keep building. In order to sort this issue, workers used long sprinkler systems and subterranean pipelines to spray water over large areas of sand. Huge metal rollers repeatedly pushed across the wet sand, pressing it until it became strong and stable. Over the day, the rollers' deafening noise bounced over the desert. The soft sand slowly solidified into a level surface. The ground became strong enough to support cars, cement mixers, cranes, and everything else the workers needed as the sun dried this surface once more. Finally, this resulted in a foundation made of water and sand that was strong enough to keep one of the biggest building projects ever tried in the area. After all the careful planning, testing, and preparation, how did the people actually begin turning this unforgiving desert into a place where a real river could finally exist? Let's find out. Once the ground was finally prepared, the digging process began. This became one of the largest excavation projects in the country's modern history. Hundreds of excavators and massive dump trucks worked every single day, removing around 70,000 tons of sand and soil daily along a path that stretched almost 250 miles. The workers had to deal with temperatures soaring above 115 degrees Fahrenheit, but the work continued through rotating shifts. The canal that they carved into the ground was shaped like a wide letter U, about 150 feet across at the bottom and roughly 23 feet deep. The slope was extremely important and had to be perfect, only 1 inch of drop for every 100 feet of distance, so the water could flow naturally without the help of pumps. Survey teams walked the route again and again, checking the ground using precise laser tools every 160 feet. Much of the sand that was removed was reused to build tall embankments along both sides of the canal, forming protective walls between 10 and 16 feet high. In places where the soil was weak, workers had to strengthen it by drilling sand piles up to 25 feet deep or by mixing clay and cement into the ground. Before long, the construction area looked like a chain of small moving cities stretched across the desert. There were temporary workshops, small concrete plants, equipment repair stations, living areas for workers, and offices for engineers. These small camps shifted along with the progress of the digging, creating long strips of activity in the middle of the empty desert. After the canal was dug, the next step was to seal it properly. The desert sand was so dry and absorbent that any water that entered the canal would simply vanish into the ground. So sealing the canal became one of the most important stages of the entire project. Workers first placed a thin layer of fine sand, about 2 inches deep, and carefully leveled it. Then large concrete panels were formed, each around 4 to 5 inches thick and sized about 16 feet by 10 feet. Between every concrete section, workers added expansion joints filled with hot bitumen so the concrete could expand and shrink safely during the extreme heat. In places where the soil underneath was especially unstable, workers added a layer of HDPE geomembrane beneath the concrete and anchored it with steel, then covered it with soft sand to protect it. In the end, more than 220 miles of the canal were covered in concrete. To protect the canal from blowing sand, workers also planted vetiver grass and acacia trees along the sides. When seen from above, the finished canal looked like a long silver line cutting straight across the golden desert landscape. In addition to the canal itself, the project required many extra structures to make everything work smoothly. These included large bridges that allowed roads and railways to cross over the canal, spillways to control flooding, drainage culverts, siphons, and aqueducts. All these structures were carefully placed to make sure that traffic could continue, floodwaters could be managed, and water flow could be controlled. Distribution gates were installed every few miles so the canal could send water into smaller channels spreading across the land. Each part had to function perfectly, because even one small failure could stop water from reaching entire farming regions. After almost 15 years of construction, the canal was finally ready for testing. Engineers opened the gates slowly and controlled the flow of water, increasing it step by step, from 500 cubic feet per second to 2,000, and eventually up to 6,000. Teams of workers walked,